Welcome back to Let's Code. I'm Chris Biscardi, and today we're going to go over this comment from James, who asks how to read this type that they found in the warp crate. They say that this is just a random example they took from the warp crate docs, that they've been trying to learn a Rust web framework, and so far Axum looks the most intuitive. But whenever they start digging into the docs for some crates, stuff like the above comes up, and it looks pretty intimidating, which I totally agree with. This is a very intimidating type to see. Would love a video of breaking something down like that function and how to read what's going on there. So the first thing I'm going to do is go find this type in the warp docs, because the first thing that I notice on this type is that it has a self argument. And what that means is that this is a function that is in an impl block for some struct. So that'll help give us a little bit of context as to what this function is doing. So all I've done here is I went straight to docs.rs. I did docs.rs/warp. I searched for recover, which is the function name. And in warp filter recover, it looks like this is the function signature that we were given. So now that we've found the type we're looking for, let's take a brief overview of what warp is in general. So the warp docs say it's a super easy composable web server framework for warp speeds. So presumably it's fast. The fundamental building block of warp is the filter. Immediately, we see that recover is a function on the filter type. So this recover function has to do with the core primitive that warp wants you to work with. They can be combined and composed to express rich requirements on requests. And this to me explains why this type is so complicated, why this type is so scary to look at, because it's meant to be super generic. It's meant to be used in as kind of the most generic, the most reusable way at the core of this very reusable HTTP library. So filters handle a lot of things: path routing, headers, query strings, multi-part form data, WebSockets, access logging, compression, and then calls out to Hyper for a bunch of other stuff. So that's about that. I would probably look at some of the examples next if I was actually going to try to use warp. I don't use warp personally. I use Axum. So we're going to continue with this type and just try to read it a little bit. From a usage perspective, you can basically ignore all of this because recover is a function on the filter type. And my guess is that they get placed in right in here. So is the path macro in here? Yeah. Let's open the path macro. So I just did Command F for path. Total guess that it was going to be in the sidebar here. And this is a convenient way to chain multiple path filters together. So warp path, some string for the path, and then like some arguments for the path as well. And then we map over that. We get these two A and B, which are U32s as arguments, and then we can return some string. So the equivalent filter chain without using the path macro looks like warp path and warp path parameter and warp path parameter and warp path end. And then we map over that. So what does warp path give us? I bet you it gives us a filter. See, I think this is the macro probably at the root. And then we've got warp filters path. Yeah. So warp path, if we look at path, wherever that is, it's right here. Path returns exact opaque, and exact is a filter. So exact implements filter. So here we should see, and then we'll probably have an and here as well. We have map, which is on the filter like we saw before. So dot map, which takes a closure and then returns something. And we have the and here, which in the example code, I don't know what that takes. F, whatever F is. We're going to go over the other one instead of going into this one. So that's the idea. This func I know we just saw. So I'm going to right click that for later. And now we're back at our type. So we've done a little bit of context setting. This is kind of stuff that you would already have probably seen if you were going to work with the actual library. You probably would have looked at the examples. You probably would have looked at the warp docs for the, how do I use this in the first place? So that brings us back to recover. So recover is a function on a filter. So if we look at the usage of these other functions, then we can say that after we do like a warp path end, we could do dot recover. And from just the contextual knowledge of the other functions, right? Like dot map takes a function here or a closure. We're just going to call them all functions for now. And if we look at recover, a literal reading of recover is something like the recover function on the filter trait takes a generic argument f. So f is just something. In this case, we use f because we're it looks like we're trying to call this a function, but we don't know that yet. All we know is that this f is some type argument that we're passing in. So self is going to be filter. I keep double clicking this and opening it and closing it. So recover, we pass in some f type to be determined at a later date. Self is going to be filter specifically, or the type that implements filter. Because remember, if we go look at the source and you're familiar with the way that traits are implemented, here, if we scroll up, we're defining filter, the filter trait specifically. So these are all just going to be function signatures that something has to implement. So in the other case that we were looking at, exact is the concrete type that was implementing filter. So this implements and, for example. And you would do that by impl filter for exact, which I bet you if we look at the source here, we will see. So struct exact, impl filter base for exact. So I'm not sure what filter base is, but it doesn't matter for our purposes. Effectively, know that filter is a trait. We have to implement recover for some concrete type, and we can pass that type in when we call this function, basically. So whatever type that is, we'll call it my type for now. If we do my type dot recover, then we pass in a function or whatever f is, because we haven't discovered that yet. And then that function call, the recover function call, will return a recover struct. So let's copy this out as well, and we'll paste this here. And I don't see the recover type here. I don't know where recover comes from. I wonder if recover comes from hyper. It doesn't look like recover comes from hyper. What is recover? I'm interested now. So where is recover defined? So recover is here. It looks like a private type, actually. I think that's why we're not getting the link to it in the documentation. Like recover isn't something that we ever use. And I bet you that if we go find recover, go for source. What was this is recover. And at the top of this file is mod recover. So source filter recover. And here's the definition of recover, which is public for this module, but not necessarily accessible to us to import. And we implement filter base for recover. And you can see that this kind of is another complicated type because Warp is trying to be a very generic piece of infrastructure. This isn't really necessarily something that you would write in your application code. So this impl filter base for recover, where T implements filter, whatever T is, some type, and F is some function, whatever. But the important part here is that recover is a concrete type and that it exists here, and we can go find out what is implemented on it and things like that. For us, knowing that it implements filter is enough. So in this case, to go over this again, we've got a function recover that is defined for the filter trait. It takes f, which we think is a function, but could be anything at this point. It accepts an argument for itself, it accepts the argument for the function, and it returns a recover, which is parameterized by self, in this case, whatever that type that we're implementing for, so my type or whatever, and the function. So this is kind of a way for us to pass through these types into the recover struct. If you look at recover, we take the T and the F. Those are the types for T and F. So T here has to implement filter, which is self, and F is the function, so yada yada. Now, in our type signature, this where clause is where we can specify additional things that these generic types have to implement. So self, for example, is going to be some type that implements filter. In this case, we're saying that it has to implement filter, and the error type on filter is rejection. It also has to implement sized. Now, it doesn't really matter what sized is here, so I think I'm just going to skip it, but know that it's another trait. So this is a way of basically saying self has to implement filter, specifically where error is rejection, and it also has to implement sized, whatever self is. So whatever we're implementing filter for. F then has to implement func with the type argument of rejection. If we click on this, it sends us to warp reject rejection, which is a struct, and it's a rejection of a request by a filter. See the reject documentation for more. So let's click on this. Rejections. Part of the power of the filter system is being able to reject a request from a filter chain. This allows for filters to be combined with or, so that if one side of the chain finds that a request doesn't fulfill its requirements, the other side can try to process the request. Many of the built-in filters will automatically reject the request with an appropriate rejection. However, you can also build new custom filters and still want other routes to be matchable. So to me, what this says is that this rejection function that we're dealing with is the method for basically guarding a route, right? Like if we want to only run a route when a certain header is set, or the body has a certain value, or can be parsed as JSON or something like that, that's what this rejection is doing. So presumably when this rejects, we have to recover somehow. And if we read the description here, we can see that that is indeed what's happening here. So we compose this filter. So whatever self is, we're composing self, which implements filter, with some function that receives an error and returns a new type instead of the same type. This is useful for customizing rejections into new response type. So there's a rejections example here, which is wonderful. If we were actually concerned about using this in our application, this is where I would go to figure out like how this is used, basically. But we're not going to look at this until after. So F has to implement func rejection. Func is, I thought I opened func before. I did open func. Okay. So func is the generic func trait, which is implemented for any function that receives the same arguments as this filter extracts. In practice, this should never bother you, simply making things feel more natural. So long story short, func is something that we are using that presumably is implemented for any closure or function pointer. This func doesn't send us anywhere else, so this is kind of all the documentation we get about this. And you can read into this if you're curious more in depth about what func actually is and does, but understand that func is another trait. So far we've basically got a stack of traits, we're basically building up a stack of exactly the requirements that we need these things to be able to fulfill, because we're going to be able to call reject on them later, for example. So when we're dealing with generic arguments, we have to specify these things very exactly. Well, we don't have to specify them very exactly, but if we have these generic arguments and we want to call a function, we have to say that whatever type you're passing in, because it can be any type, has to implement these functions in these ways. And the way we do that in Rust is through traits. So this is saying self has to implement filter and sized. F has to implement func with the rejection struct passed to it. The next one is a little bit interesting. F has to have an output type that is associated with it. So this is called an associated type. And the output type has to implement TryFuture and send. So associated types in Rust you can find in the book. This is exactly what it is. If we have some trait and we define type A, type B, for example, one of these would be type output, those are the associated types. So then we can say things like, we accept an argument of self A, which refers to this type, or self B, or returns self C, or something like that. So for our purposes, F has some associated type called output, and whatever we decide to make that type when we implement this trait has to implement TryFuture and send. Now, send isn't super interesting, and TryFuture is basically async await kind of stuff. So I'm not going to dive into the implementation details of those traits, but know that TryFuture is something to do with futures and async stuff, and send is something to do with something else. It doesn't matter. Now, building on that syntax, the next syntax says if we treat the associated type output on this F type that we're passing in, that we're implementing the trait for, if we treat that as TryFuture and we take the error associated type on TryFuture, that has to implement IsReject. So that's a little confusing, right? So we've got some type, like my type, it has an associated type called output. That associated type, if we are treating it as a TryFuture, we're basically saying treat this as TryFuture because there can be other things named error that are an associated type on this struct. We want the one that implements TryFuture specifically. If we get that error has to implement IsReject. And we could go look up what IsReject means and whatnot. But most likely, in this case, we aren't going to be dealing with these things very much. So now that we've gone over this, I'll say it one more time. The recover function that is defined on the filter trait takes a generic argument F and operates on itself. So you can call this function on the concrete type that implements filter. You have to pass in a function of some kind, and it will give you back the ability to recover, or a recover struct that is parameterized by the type that we are defining this on and the function that we're giving it to. On top of that, self has to implement filter and sized. F has to implement func with rejection. The output associated type on F has to implement TryFuture and send, and the output associated type with F, because it has to implement TryFuture, has to have an associated type error that has to implement IsReject. So in this case, we have div with header or div with body dot recover, and then we pass in handle rejection. So if we think about what we learned here, handle rejection is going to be that F, right? So handle rejection is probably going to be something that implements async. And if we go look at handle rejection, it is an async function, right? So the function receives a rejection and tries to return a custom value, otherwise simply passes the rejection along. So if we look back at our type here, we now understand that F needing to implement func rejection means that we need a function that accepts a rejection type. If we look back at our handler here, it accepts a rejection as the first argument. So that's what that func trait is doing for us in that type signature, is basically defining the type that this function will have to be able to handle. And then here, there are no restrictions on that output type other than TryFuture, send, and the error being IsReject. So infallible comes from standard convert infallible. This is probably not going to be something that we're going to be able to search for. Let's look for it in the GitHub repo. You can see that a bunch of these other functions, for example, optional, requires the return type to implement filter, where the error is infallible. And somewhere here, I'm expecting to see IsReject, but maybe I'm looking in the wrong place because I'm not that familiar with Warp itself. So here's create reject, IsReject. Where's the definition of IsReject? Let's go back into the repo, source, reject, and then somewhere in here should be IsReject. They're sealed, so we're not really supposed to touch them. I'm assuming that this means they're private. But here's the IsReject implementation for infallible, which the type signature told us had to exist. You can see that the output type here, the error associated with the output type, has to implement IsReject. If we looked at, I got rid of that, didn't I? Let's go all the way back to our example. We've got this output type then here, where it's a result, and therefore the error type on this result has to implement IsReject. So that's how we knew that this implementation had to exist. Now, in this case, it doesn't actually look like it does anything. It looks like an identity of some kind, which makes sense because infallible is like cannot fail. But in our case, we're just looking for the fact that this IsReject is implemented for infallible. So that's the type. It takes a while before you can kind of read that and dig into it like that. The thing that I would say here is that these types are generic for a reason. They're generic because Warp is a piece of infrastructure. It's not necessarily application code, if that makes sense. I would expect application code to be simpler and to not need this many kind of generics and trait restrictions. But I hope that this helped. I hope that next time you'll come into this and you'll see this and you'll go, oh yeah, that's an associated type. This type signature specifically, I know also shows up when we deal with SQLX and creating, I believe, custom types in SQLX for serialization into the database. But yeah, so that's how I would go around with a library I'm fairly unfamiliar with. I don't use Warp for many things. I tend to use Axum myself. That's how I would go through and read this type signature at a deeper level than just what do I do with it. If it only matters to me what I do with this on like an application level, then we can go look at the rejections, we can write this function, and we can be done. There's nothing else that we really need to do. We don't need to write this handle rejection function. We do not need to understand all of these types, but it can be very helpful if you do. So I totally get it. These types are big. These types are scary. They're kind of verbose. But what's happening here is we're defining some argument that the user is allowed to define later, or some other library is allowed to define later, that implements this function for this trait. And when it does that, we're trying to restrict it as little as possible, but as helpfully as possible as well. So when we want to call reject on these types, we can, but we don't require the type to do anything it doesn't absolutely need to do. So that's that. I hope that helped. I'm happy to anytime go over any types that any of you have. Any questions you have about reading documentation or searching things. I hope that the process of me looking these things up manually on the video. Helps you find a few new places to look for things, encourages you to click the source button here on the right, encourages you to go to the documentation or go to the GitHub repo and do these searches. And I will catch you in the next video. Later.